All right, good morning. So today we're going to go ahead and hit the second half of our topic of polynomials, and we're going to start talking about factoring. Before we can start talking about factoring, we have to talk about something called the greatest common factor, or better known as GCF. Right? So the GCF is the largest value that all your monomials will have in common. All right. So what we're looking for when we're talking value, we're talking numerical value as well as the value of a variable, or how many of variables they have in common. And the variables are usually the easier part to go ahead and do. So we're going to do a bunch of examples with a lot of numbers. And hopefully this will start to make a little bit of sense. But what we don't want to confuse this with, this is not the same as when you're going ahead and dealing with a lowest common denominator or lowest common multiple when we deal with fractions. With fractions, we're working with making them the same by multiplying things to make them equal. In this case, we're going to be doing division to take out what they have in common. And I'm hoping this will make a little more sense as we go through the video today. All right. So my first example, I have 9 and 18. All right. And what I want to look for is what do they have in common. And there's a couple ways I could go ahead and do this. Obviously, I know that 9 times 2 is 18. All right. So they should both have a 9 in common. Another thing you can go ahead and do is take the bigger number and think about what times what gives you 18. All right. And some of you may see 9 and 2. That's cool, and you see it right away because you know your multiplication. Some of you may see 6 and 3. Okay, that's also okay. All right. If you see the 6 and 3 and not the 9 and 2, then remember 6 will also break down into 2 times 3. Okay. So we know 9 times 2 is 18. All right, so I know they should have a 9 in common. All right. I'm going to go ahead and break the 9 down into 3 times 3. All right. So what I can look for here is if I didn't know that 9 times 2 is 18, and I still wanted to find what they have in common, I could do my little factor trees as we've done in the past and look for matches. Okay. So in this case, this 3 matches up with this 3. And this 3 matches up with this 3. And so everything that's circled, just for each one, if I know that 3 times 3 is 9, so they must have a 9 in common. All right. Now this seems silly the way I did it, but let's kind of think about this when the numbers get bigger. Okay. So you can only take out from a pair of numbers or a trio of numbers, monomials, if they have something in common. In this case, it was really easy. They all both had a 9 in common. Okay, so that would be my GCF for this case. All right. If I have x cubed and x squared, I want to take out their GCF or find out what they have in common. The best way to go ahead and for variables, what they will have in common is the lowest exponent. Okay. So as long as you have the same variable, the lowest exponent from all your values that you're given will be your greatest common factor. So I should be looking at the 2 here. 2 is smaller than 3, so they should have an x squared in common. Let's go ahead and look at it in the form of a factor tree. Okay. So x cubed is x times x times x. X squared is x times x. And if I go ahead and circle 1 for 1, I see that indeed they both have 2 x's in common, or x squared. So today we're focusing on identifying greatest common factors, not necessarily doing anything more with them than that. Okay, I encourage you to try any of these beforehand and then go ahead and restart the video. I'm going to go through quite a few examples here. Okay, so we have 18x squared and 27x. The variables are going to be the easiest. Okay, remember my x here has an exponent of 1. And remember, for variables, my lowest exponent is what they're going to have in common. So these guys have an x in common. The numbers are going to be a little trickier. All right, we'll move this x out. Okay, put them over here. All right, so my numbers, 18 is 9 times 2. We've already been through there. 27 is 9 times 3. Sorry, 18 is 9 times 2, 27 is 9 times 3. It's early. So they both have a 9 in common. I don't need to break it down anymore if I see it. And so my GCF in this case would be 9x. Okay, here I have 3 sets of numbers. All right, one of them happens to be a 2. And I'm going to give you a little hint. If they're all even, they're going to have a minimum of 2 in common. Seeing as one of my numbers is actually 2, my GCF is going to have a 2 involved, because that's as much in common as they're going to have when I only have a 2 here. Then I look for my smallest exponent. I have a squared, or a to the second power. I have a to the first power, and I have a to the fourth power. My smallest power is my 1. So they're going to have a 2a in common. All right, let's go ahead and look at this one here. Now I have 7 and 18. They both have one y. Okay, so a y to the first. Remember, your variables are your easiest. And so I know they have a y in common. Now 7 is 7 times 1. 18. There's no 7. I get either 6 and 3, 9 and 2, 18 and 1. But 7 isn't a part of that. So the only thing this actually has in common is just the variable y. Okay, so my GCF in this case is just y. And then I have 3x and 13y. I'm looking for my GCF. Now my letters are different, and my numbers, 3 does not go into 13. They're both prime numbers. This one does not have one. So as we go through factoring, this will usually be the first thing we do, is look for that GCF. If it doesn't have one, you move on. Okay, so I purposely put one here that just doesn't have a GCF, and that's okay. But you want to make sure that you're always looking for one. Making the numbers go just a little bit bigger for you. Okay, I'm going to look at my smallest exponent first. In this case, I have a x squared. So I know an x squared is in my GCF. And now I have 64 and 72. Okay, and depending on how well you know your multiplication tables, you might be able to see really quickly what my GCF is. Okay, my GCF for the numbers in this case should be 8. But you're like, wait a minute, what if I don't see that? Let's go ahead and look at this. All right, so if you're unsure where to start with a number, start with 2. In this case, we should know these from our multiplication tables. 64 is 8 times 8. 72 is 8 times 9. Okay, and there's my 8 appearing in both of these. And I don't have to go any further than that. Okay. So if it's something that you just know from the multiplication tables, go ahead, break it down into that and pull that number out. The last one's going to be a little bit harder. This one I may want to go ahead and break it down. Okay. I know I'm going to have one a in common because my smallest exponent is 1. So start with the variables first. Now I got to deal with 132 and 96. Okay. You can pick any number that divides into both of them or what they have in common. I see they're both even. Okay. And seeing that they're both even, I'm going to divide each one by 2. Okay. So I know they're going to have a 2 in common. Okay. When I go ahead and pull out the 2, I have 2 times 6 will give me 12, so it should be 66. Okay. And 96, if I divide by 2, 4 and 8, so 48. Okay. And now we're going to go ahead and keep going here. So we know that they have this 2 in common, and I like to circle them as I'm going through my factor tree. Okay. And now I'm going to look at the 66. Well, I know 11s all go in double digits up until they hit 10. Okay. So I know that 66 is 6 times 11. And 48, I know 6 times 8 is 48. Okay. And here we have matches again with 6. I don't have to break it down any further if it appears. Now, if you didn't see the 6 and the 48, that's fine also. All right. And we're going to go ahead and use that to go ahead and help us out. Okay. And now I have 8 and 11. Now 11 is prime. So 8 and 11 are going to have nothing more in common, which means what's in common is 2 times 6 or 12. So each one of these, my GCF here is 12A. And you don't often get a bigger number, at least not in this class, but we're going to go ahead and sometimes those numbers tend to get a little larger. All right, so go ahead and practice with GCFs today, and then I will see you in the next video.